right, hi everybody. In this video, we're gonna continue our discussion that we started last video about ways that we can classify matter. So one of the other ways we can classify matter is into element or compound. So sometimes you'll hear me say substance, and when I use the term substance, I'm talking about any sample of matter that has the same physical and chemical properties throughout the sample. So what does that mean? It means if you have, like a block of some kind of piece of matter, if I take a chunk of the block from over here and compare it to a chunk of the block from over here, you're going to find the same physical and chemical properties in each of those chunks. All right, so there are two different types of substances. The first is elements. And so elements are a type of substance that cannot be broken down into chemically simpler components. So what does that actually mean? So if you look at this helium right here that I've drawn an arrow to, the element helium, which you'll also find on the periodic table of elements, it can't be broken down into anything simpler, right? It's kind of as simple as it gets. It's the element helium. If I break it down anymore, I don't have the element helium. I have some other things that we'll talk about in the future. But for right now, you can think of elements as kind of the simplest substance that we can't break down any further. Compounds are similar but different in that they're usually composed of two or more atoms. So, right, this is a hydrogen atom, this is an oxygen atom, and this is a hydrogen atom. And we'll talk about what atoms are in a little bit. But we're really familiar with this compound. This is water, H2O, and that 2 here represents how many hydrogen atoms we have. And then there's an invisible 1 next to the O there, and that tells us we have 1 oxygen. So it can be broken down into hydrogens and oxygens, but the compound water is H2O. So I think this can be a little bit easier to kind of wrap our heads around with some examples. So let's try this practice out. Again, pause the video and try it out on your own, and then come back and we'll talk about it. All right, hopefully you tried that out. So for the first one, carbon dioxide, is that going to be an element or a compound? Yeah, that one's a compound. It's composed of 2 or more elements, and we could break that compound down into elements, individual elements. So the element carbon and the element oxygen. Excuse me. All right, so number 2, nickel. Is that one an element or a compound? Yeah, that one's an element. If you go onto the periodic table, which we'll get really familiar with if I didn't mention that already, but if you go onto the periodic table, you can see nickel is just on the periodic table. It's one of the one of the elements on the periodic table. Just exists as nickel by itself. Okay, so that's an element. Aluminum, same idea. It's just an element. And then methane is what? Yeah, compound. 2 or more elements bonded together. And sometimes you'll hear 2 or more atoms bonded together in a fixed ratio. So what do I mean by that? I mean that when you look at carbon dioxide, anytime you have carbon dioxide, you have CO2. You have 2 oxygens bonding to 1 carbon. Same thing with water, right? Anytime you have water, you have 2 hydrogens bonding to 1 oxygen. Right? Same thing with methane down at the bottom there. 1 carbon is going to bond with 4 hydrogens. We'll talk about bonding in the future, and it's one of my favorite chapters. But for now, just think of these compounds as kind of in a fixed ratio, right? All right, so then there are these things called atoms and molecules. So the smallest part of an element, so if we looked at an element and we kind of zoomed in really far, you'll eventually get to atoms of that element. So over here, we've got some bars of gold, and the symbol for gold is AU. Okay, but we've got some bars of gold there, and if we zoomed into one of these bars very far, like extremely far, we would eventually get to gold atoms. All right, and then looking at that second bullet point there, it says the smallest part of a substance that maintains the identity of that substance is called a molecule. So we'll do a little bit of a deeper dive into molecules here. So there are different types of molecules, and I think these will start to make sense once we kind of look at some pictures of different types of molecules. So there's diatomic molecules. Those are ones that contain molecules that contain 2 atoms, right? 2 di, right? So something like N2, that's nitrogen bonded to itself, that's a diatomic molecule. There are two nitrogens bonded together, two nitrogen atoms bonded together. Then there are also triatomic molecules, just like the name suggests. With triatomic, those contain 3 atoms. So these are things like water or CO2, right? They've got 3 different, or 3 atoms. So water is a triatomic molecule. And then there are polyatomic molecules, and these are ones that contain more than 3 atoms. More than 3 atoms. So something like sugar, that contains a bunch of different atoms, right? Quite a few, actually. So we can also break this up into a couple more categories. Lots of categorizing this video. So there are homoatomic molecules and there are heteroatomic molecules. So homoatomic molecules, they have atoms that are the same type of atoms, okay, bonded together. So for instance, in that N2 example up here, we had nitrogen, we said was a, let me show you here what I'm looking at. We said nitrogen was a diatomic molecule because it contains 2 atoms. And those atoms are the same types of atoms, right? They're both nitrogen atoms, 2 nitrogen atoms. So we would say that N2 is diatomic and homoatomic. It's both, okay? All right, and then heteroatomic molecules, these are when we have 2 or more kinds of atoms. So remember up here, now looking at water, we said that water was a triatomic molecule because it contained 3 atoms. And those different atoms, there are 2 or more kinds of them. So we could say that water is a triatomic molecule and heteroatomic. So it can be both, okay? So just thinking of different ways that we can categorize these different molecules. All right, so another way that we can kind of categorize matter is with mixtures. So we call a mixture anything that is composed of 2 or more substances. So let's rewind for a little bit here, and I hope I don't make you dizzy. But we said that a substance is any sample of matter that has the same physical and chemical properties throughout the sample. And we said that the 2 substances are elements and compounds. Elements and compounds. So let's go down here, back to our mixtures. And so a mixture is something composed of 2 or more substances. So we take either an element and another element, or an element and a compound, or something like that, and we create a mixture. And we break those mixtures up into 2 categories. There's heterogeneous mixtures, which are these mixtures with where you can see all of the different parts of the mixture, right? And then homogeneous mixtures, which are kind of the same composition throughout, where you can't really see the different parts of the mixtures. So let's think about this for a little bit, because I know this is a lot. So heterogeneous mixtures, if we look at this kind of veggie medley here, we can see all of these different parts of the mixture. We've got some broccoli, we've got, I think, celery, we've got carrots, whatever that, I mean, I don't know what that is, maybe a mushroom or an onion or something. And we can see and pick apart all of those different parts of the mixture. And then we've got, and so that would be heterogeneous. And then we've got homogeneous mixtures where I'm putting in a banana and an apple, and I'm making a banana apple smoothie. And in that smoothie, if you blend it long enough, you're not going to see the different parts of the mixture, right? You can't really pick apart, hey, where is my banana and where is my apple in there? So it's the same throughout, or uniform composition throughout. That makes it a homogeneous. So I like to think of it as same and different. All right, so let's practice this a little bit. So pause the video and come back. Okay, so a pepperoni pizza, is that heterogeneous mixture or a homogeneous mixture? That one's going to be heterogeneous, right? You can see all of the different parts of, sorry, try to spell and talk at the same time. You can see all the different parts of the pizza, right? You got your pepperoni, you got your cheese, you got your sauce, you got your crust. Heterogeneous. You can see all those different parts of the mixtures and separate them, okay? What about a milkshake? Yeah, that's homogeneous or homogeneous. I don't know. I hear it said either way. So whatever works for you. But yeah, a milkshake is homogeneous. And why is that? Well, that's because if you look at your milkshake, if it's, you know, done well, right? You shouldn't be able to pick apart the different parts of the milkshake, right? It's the same throughout, homogeneous. Spaghetti and meatballs is heterogeneous, right? You can pick apart those different parts of the mixture. And then tea and sugar, when it's dissolved, when the sugar is dissolved. Homogeneous, yeah. Because it's the same throughout. You can't pick apart the different parts of the mixture with your naked eye. And so I'm not going to answer this question, but I want you to think about, how are these mixtures different from substances? What's the difference here? Okay, because you can't, if something is a mixture, it's not a substance. It's composed of two or more substances, right? Two or more substances. So a compound cannot be a mixture. A compound is a compound. Okay? All right. You can put compounds in something and dissolve them, and you can make a mixture, whatever. But you can't have both. Okay. So when I ask you to kind of categorize these different things, you can say something is an element. You can say something is a compound. You can say something is a heterogeneous mixture or a homogeneous mixture, but they can't be more than one. Okay. You got to pick. All right, I think that's where we're gonna call it for this video, and I will see you in the next one.